This is the Change Underground. I'm your host, John. Decarbonise the air, recarbonise the soil. Welcome to episode 4 of season 9. And today's episode is all about restoring ecosystems. So after a nearly 6-month hiatus, we're back, baby. Ill health, a bad dose of RSV, then COVID, then general lack of stamina, a certain depression at the shape of the world, life interfering with the joys of podcasting, and a period of great flux in my life. I've returned with a renewed sense of purpose. Having basically re-engineered my life to be how I'd like it, I now have more creative space to play with. I'll stick with the seasonal structure for the show. I think that's a goer. The enforced periods of rest are something I've scheduled into my life anyway. Rest was something very underappreciated by your narrator. I have learned my lesson. So let's get into the episode. In the face of pressing environmental challenges, the need for a sustainable agricultural practice has never been more urgent. And one approach that actually heals the planet is, of course, regenerative ag. This episode digs into the environmental impact of regenerative ag, and I'm fully aware of the irony of that statement. How does it restore ecosystems, mitigate climate change, and conserve biodiversity? Well, let's find out. The world's ecosystems are under immense stress due to a range of environmental issues, including climate change, soil degradation, and loss of biodiversity. Chemical farming practices have contributed to many of these problems, but regenerative agriculture offers a promising solution. It's an holistic and sustainable approach that focuses on restoring the health of ecosystems rather than depleting them. Soil regeneration. At the core of regenerative ag is the restoration of soil health. Healthy soils are the foundation of any ecosystem, supporting the growth of plants and the well-being of larger organisms. Chemical ag, with its heavy use of synthetic fertilisers and pesticides, has caused widespread soil degradation, killing off not just perceived pests but all types of soil biota. Regenerative agricultural practices, such as minimal tillage, cover cropping and diverse crop rotations, enhance soil health. These methods promote the accumulation of organic matter, which increases soil microbial activity and improves soil structure. As a result, the soil can hold more water, making it more resistant to droughts, and it captures and stores carbon, mitigating climate change. Win-win. So, carbon sequestration. One of the most significant environmental impacts of regen ag is its ability to sequester carbon. As plants grow and die, their organic matter is incorporated into the soil. In healthy regenerative systems, this carbon-rich organic matter accumulates, essentially storing carbon in the ground. Decarbonise the air, recarbonise the soil, perhaps? This process is crucial for mitigating climate change by reducing the concentration of atmospheric CO2. While soils can both sequester and release CO2 over time, on balance, a regenerative approach is tilted towards increasing soil carbon over time. So the mitigating of climate change, the carbon sequestration potential of regenerative ag is substantial. By capturing and storing carbon in the soil, regenerative practices actively reduce greenhouse gas concentrations in the atmosphere. This approach aligns with the goals of the Paris Agreement and international efforts to limit global warming. Regen ag is an important tool in the fight against climate change. Indeed, it may be our best tool in reversing CO2 concentrations in that atmosphere. Biodiversity. Regenerative ag promotes biodiversity conservation, which is essential for the stability and resilience of ecosystems. Chemical farming practices have led to the destruction of natural habitats, the use of monocultures, and the application of chemical fertilisers, chemical pesticides, all of which destroy biodiversity. In contrast, regenerative agricultural practices foster biodiversity by creating diverse agroecosystems that provide habitat and sustenance for a wide range of species. Hedgerows, cover crops, and reducing and eventually nil pesticide use encourage beneficial insects and other wildlife to thrive. In addition to supporting a more balanced and diverse ecosystem that helps control pests naturally, and thereby reducing the need for harmful chemicals, the point is to create a complex system. Contrary to mechanical systems, a more complex biological system is more stable than a simple one. Reduce chemical use. Chemical ag, as the name implies, relies heavily on synthetic pesticides and herbicides to control pests and weeds. Unfortunately, this results in the contamination of soil and water, harming both ecosystems and human health. Regenerative agriculture minimises the use of these chemicals, opting for more natural and holistic pest management techniques, the goal being, of course, the complete elimination of these chemicals. By reducing chemical use towards zero, regen practices protect not only ecosystems but also consumers. Reductions in pesticide residues on food products is healthier for consumers as it lowers the risk of pesticide exposure. The rise in the vast majority of chronic illnesses plaguing the world nowadays can be traced back to the more widespread use of farm chemicals. This is a correlation which does not, of course, imply causation. However, the growing body of evidence would suggest the link between chronic ill health and ag chemicals is more than casual. Water quality and conservation. Regenerative agriculture also has a positive impact on water quality and conservation. By minimising soil erosion through practices like cover cropping and removing the possibility of chemical runoff, regenerative farming helps protect water bodies from pollution, ensuring cleaner, healthier water sources for both aquatic ecosystems and human consumption. Now, this chain links all the way to the ocean depths. Truly, everything is linked to everything else. Additionally, practices like no-till farming and organic mulching enhance the soil's water holding capacity. This reduces the need for irrigation and supports water conservation, a critical factor in regions with water scarcity. These practices also mitigate the effects of floods as the water takes longer to reach rivers, streams and creeks, allowing for water flow to be maintained at safer levels, well, safer for human habitat anyway. Resilience. With the increasing frequency of climate-related events such as droughts and floods, building a resilient agricultural system is crucial. Regen Ag, by improving soil health and water retention, enables farms to better withstand the impacts of these extreme weather events. It provides a safety net for farmers and helps maintain food production even under challenging conditions. A regenerative safety net grows stronger and deeper and more resilient over time. It's likely will be subjected to some really wild weather extremes in the coming years. I write this in mid-April 2024, halfway into autumn in the northwest of Tasmania, 40 degrees south of the equator and the roaring 40s trade winds. And I've been wearing a t-shirt in the afternoon for the past month. When the cold weather arrives, or is that if the cold weather arrives, an extreme cold snap driving in off Antarctica would not be a surprise. This is our fifth winter coming on this piece of ground, and the ground cover is much increased from when we took over the block of land. I'd like more, of course, but regen is a process and a journey, not a destination. Soil erosion. Soil erosion is a significant environmental issue leading to the loss of fertile topsoil and the degradation of landscapes. Regen Ag, with its focus on minimal soil disturbance and cover cropping, effectively reduces soil erosion. This helps protect fragile ecosystems and prevents the loss of valuable soil resources. The US Dust Bowl of the 1930s should have taught us all about the importance of keeping soil in place. The chemical solution, no pun intended, is to pump more fertilisers into the ground to make up for lost topsoil and its associated microbiota. To, in effect, create a giant hydroponic system with subsoil as a growing medium. Not, I would suggest, a sustainable practice. Sustainable water management. Regen Ag practices, such as the creation of water-retaining landscape features like swales and ponds, support sustainable water management. They capture and store water, preventing runoff, and help recharge aquifers. Sustainable water management not only benefits agriculture but also local ecosystems and communities. And as I said before, these upstream water catchments are connected to the ocean depths. What goes in at the top ends up at the bottom, passing through any number of biological layers, heavy metals, some pesticides, and maybe even microplastics, all bioaccumulate in increasing concentrations as they travel through the ocean food chains, heading quite often into the human food supply. Clean soils equal clean fish. The path forward. The environmental impact of regenerative ag cannot be overstated. This holistic approach has the power to restore ecosystems, mitigate climate change, conserve biodiversity, and protect water sources. By embracing regenerative ag, we can work towards a more sustainable and environmentally safe food system. Consumers can play a vital role in supporting regen ag by choosing products that are grown using these practices and advocating for sustainable farming methods. In so doing, consumers help accelerate the positive environmental impact of regen ag and contribute to the restoration of ecosystems and the preservation of our planet in a state fit for future generations. Well, thank you for listening, and I'll be back next week. Good to be back. This has been a JM Podcasting Services production. Link in the show notes.